Hello everyone. Today we will be discussing about SSL certificates. Let me get you the agenda. So we'll be having introduction, then we'll be looking at into some use cases of certificates. Moving on, we will look into the certificates, how it works. We'll be discussing the history evolution, differences between TLS 1.2 and 1.3. How does OpenSSL is helping us in setting up the certificates? And finally, what are the best practices and industry guidelines about it? Moving on to the first discussion, which is the introduction. So SSL, which is TLS certificates, are essential for securing the data. It also helps in authenticating the identities and enabling the trust across web applications. Uh, TLS SSL protects confidentiality, integrity of sensitive information. Certificates also prove identity and prevent impersonation. There are several network protocols that computers use to communicate over the internet, and here are some of them. Almost every protocol which involves a data transmission, there is a secure counterpart for those protocols. Like we can see here, HTTP has got a secure version of it called HTTPS. Similarly, FTP has got FTPS, Telnet, SSH, likewise LDAP-S. So let's discuss about a few use cases where the certificates are useful. The first example that we can think of is online banking. So we all do online transactions wherein being customers of the bank, we log into the portal of the bank and then while logging in, we provide the credentials. Having the SSL certificates and TLS certificates enabled, whatever credentials we provide, they get encrypted, and that is why the hackers can't steal them. And that's how we implement the security here. Similarly, in case of email encryption, which is the second use case, whatever email exchanges are happening, they happen on the secure protocol SMTPS, which is why they are encrypted and no one can, look into the emails of others. Uh, One another example is e-commerce, wherein a famous man in the middle attack is being discussed, where we use the credit cards to pay the stuff that we are buying in. So while filling in the details of the credit card, if we have the secure certificates involved, whatever credentials and whatever card details we are providing, all those is secured. It gets converted into a language which the hackers can't understand, even if they get that information. Finally, last example is of IoT devices, wherein what happens is the smart devices that we use, like cameras and sensors, they exchange data with the application server. With security, the data communication happens securely, as well as the devices are very much secure. They cannot be controlled by the third-party systems. Moving on, we will discuss about how the SSL and TLS certificates work. For this, I have one example from the movie Diwar, which is a Bollywood movie. Let's quickly look at this scene from the movie, what they are doing. So here exactly, if we see these two people are exchanging a note, a currency note, and they're trying to match if the currency notes, stolen currency notes are valid. And once they are validated, then only they exchange, whatever boxes they have. And this is how we can take an example, right? So keeping this example in mind, if we think about how the SSL works, so this is what the flow looks like, right? So we got a client, we have a server, and between them, when the data exchange happen, this is how the communication happens, right? So there are three stages, three phases of it, as the boxes indicate here. First phase is to establish the TCP connection, wherein a synchronization request is sent by the client and the server acknowledge the synchronization request. The second phase is all about exchanging the valid certificates and making the trust here between client and server. So in this phase, the client sends a hello message along with the cipher suits and the versions that are available. Server in exchange selects the cipher suit and gives the certificate of the server, which then the client validates using the entity called as certificate authority, shortly called as CA. And then once it is validated, that's how the secure connection is established between the client and server. And once that connection is established, that's where the data exchange starts. And whatever data is getting exchanged on this line is now encrypted. So here is what the phases looks like. So phase one is TCP connection setup that we just discussed. Phase two is about all this, right? So client sends the supported TLS version, cipher suits, etc. So server chooses the cipher suits, TLS version, and sends its digital certificate. Then client validates the server certificate using the CA, certificate authority. And then that's how, client sends the key material, which is the master secret, to derive a shared symmetric key, and server confirms handshake completion and readiness for the encrypted communication. So this actually sets the secure connection over the line. And finally, the phase three is about encrypted data exchange, where actually the client sends a request over the encrypted channel, and this is how the server and client they exchange the information. Let's quickly look into the history of the the certificates. It started with SSL, SSL 2.0 to 3.0, and then we had TLS versions, TLS 1.0, 1.1, 1.2, and 1.3. This table indicates, which version was introduced when, but most importantly are the last two rows here. So TLS 1.2 is widely used because all the legacy applications which were written, let's say 10 years, 15 years ago, they all are onto this version, TLS 1.2, and that is why it is widely used. But the most latest one was introduced in 2018, which is TLS 1.3, and it is more, recommended one. Why it is recommended, that comes up in the next slide. So this is what the difference between TLS 1.2 and 1.3 is. So TLS 1.2, it gives a full handshake requires two round trips, as we saw in the earlier diagram. Supports older ciphers because, as we know, right, this was introduced back in 2008, and that is why the cipher suits that were introduced that time are now, not so secure. We have even secure versions of them. It is flexible but heavier, and as we discussed, right, legacy applications are still on this TLS version. TLS 1.3, it is faster. It takes only one round trip, removes the weaker ciphers that were introduced earlier, and more importantly, it gives us the perfect forward secrecy, which is a very important concept. What it indicates is whatever communication is happening, it is happening with a unique key every time, right? So it is like changing the lock of your door every time you get out of the door, and that is why even if the key is found to somebody else, the next day for the next iteration the key will be changed, and the key that is found by somebody else is of no use now. So it gives as the name indicates, perfect forward secrecy. So it gives complete protection. It has more stronger and more efficient encryption, and all the modern apps, mobile apps, they are all on the TLS 1.3 version. Let's get introduced to a very important topic, which is the tool called as OpenSSL. It is a very common tool which is being used when it comes to creating the certificates. Let's quickly look into this. OpenSSL is an open source toolkit that provides cryptography libraries using which we can, implement the encryption, decryption, hashing, these kind of algorithms, implementation of SSL and TLS protocols, and command line tools for managing keys, certificates, and secure connections, right? So Along with certificate management, OpenSSL is used for testing and debugging purpose as well. And OpenSSL can be used by all the different people with different roles like developers, DevOps, and testers as well. For example, developers can use OpenSSL to inspect the certificates to do the debugging for the handshake. DevOps guys are the like the people who mostly use this OpenSSL because they deal with creating the keys, the certificate signing requests, certs, etc. And testers can also use the OpenSSL tool to validate the certificates and their TLS version, right? The last one is about what are the best practices, right, and the industry guidelines. So here are the ones. There are many, but we'll discuss about a few. Like use TLS 1.3 or TLS 1.2 if needed, more preferably TLS 1.3 to take the advantage of most secured protocol. Use strong ciphers only. Even if you are on TLS 1.3, whatever strong ciphers are there, we should prefer them. Protect private keys, which is very important. So private keys are the ones using which we create the certificates. So if in case anyone gets hold to these private keys, then they can create a copy of your own certificates, and then you have a problem with your security. So private keys are most important. We should store it and give minimum access to it. Enable perfect forward secrecy. We discussed about it a few minutes ago. And then a very important one, rotate certificates regularly. So whatever certificates we are having, we should keep on, renewing the certificates. That's very important.